I will slowly start. Thanks for coming in our today event, the Java User Group Munich. And I would like to talk a bit about microservices and monolith applications. The topic, of course, is not new. And there are a very lot of debates of this topic last time. I just would like to summarize my own experience working with a client and make one concrete example. We will look at what's the initial design of the system, how system grows, and basically the idea is to find a balance between monolith and microservice, because it's just two architectural style and there is not good and bad, not right or wrong. So you really should adapt these architectural styles for your use case and up and use what is more effective and more flexible and basically brings you forward your business. So my presentation contains some parts. In the first, make very short introduction. What is basically the architectural style, monolith and microservices? What is the different? After that, I will dive in the one concrete use case was made in the e-commerce area. I explain what was the setup, how team looks like, what is the initial system design was, what was good, what was bad, and after that, which pain points we have, and how iteratively to solve it. So very important from my point of view, also by split and by migration architecture from monolith to microservices to do it iteratively, not as big bang. Yeah, also we will look which are the challenges and what the issues are appears with microservice architecture, because it's not a free lunch, and make some conclusions and recommendation, and of course discussions and answer the questions. Regarding the question, you can ask every time the questions. I also will make a small breaks after the every section. I'll try to make it to answer the question, and just answer, break me every time, and I would like to have kind of discussion more as a solo talk. Okay, let's go ahead. Shortly about me. I work as a software engineer in the VMWare Tanzu Labs, is a new name for pivotal company, and make some contributions in the open source project, mostly in Apache, is Apache CXF, Syncope, Karaf, and sometimes I speak into technological and methodological conferences. Okay, monolith and microservices, what is the difference? So from my point of view, are some key attributes of the architectural style we can recognize as a monolith system or microservice system. The first of course, system design, that monolith built as a single system. Microservices is more or less subset of more or less independent subsystem. Of course, they have some relations through the API, but they are in the certain grade independent. And this decision how to the system organize, how they split it based on the business subdomain. It's not because of some technological is, but it's really from business in the domain-driven design, the binding context. Next is a code base. So normally monolith use a single code repository. Of course, it would be more than one, but as rule, monolith has a single code repository, and microservices has a repository per subsystem. Deployment, very important. Yeah, this is the case sign of monolith, that you can deploy only all or nothing. Yeah, so either you deploy the whole system, they live as a single process, and microservices you can deploy the subsystem in still deploy the new version of one and stay with the old version of the another. Data store Monolith as a rule, again, should be not always the case, but normally they use single shared data store. And in microservices case, every subsystem should have, also this rule is broken, is violated very often, but in the classical case, every microservices owns its database. So it's completely independent. Communication, a lot of local communication inside application using between the modules in the monolith in microservices. Because of the independent cost of that we have a lot of remote communications, either synchronous or asynchronous. And the technology, normally the monolith is limited to use one technology. Theoretically, you can use in single Java virtual machine also different languages, programming languages, but as a rule, is one single technology stack. And in the microservices case, you have a choice to implement different subsystem, different microservices using completely different technology stacks. It could be one microservice with .NET, another one with Java or Kotlin, Java-based languages, and so on. So it's completely open. It shouldn't be the case always. You still can use the homogeneous technological stack even for microservices, but as a rule, so as an option, you can use a different. Okay, let's look into the concrete project. It was some years ago, or it started some years ago. The task was to implement the backend for classical e-commerce system to provide REST API and some functionality to manage users, carts, checkouts. You can put something into the cart, go there to checkout, pay for the orders, make a fulfillment, initiate a fulfillments, and so on. So it's a very classical e-commerce use case. Those three teams, every team about 7-8 persons. And initially we use as technologies Java, persistence layers, Hibernate, and Postgres, Apache CXF for as REST implementation, REST API, ActiveMQ is asynchronous communication, and the project was deployed in the OSGI and the Kara. And we use a Scrum methodology. If we look inside, so in the initial system architecture, system design, there's a part in the middle is the middleware that exposes some REST API used by the browser, front-end, mobile applications, some external consumers. And internally, middleware, I already said, to use SQL, SQL, not SQL database to store the data, as ActiveMQ for asynchronous communication for messaging. Should call SAP or must call SAP for fix financial payments and orders and fulfillments. It goes through the SAP. And they have some connection also with online payment system like PayPal, Ingenico, PayU. And let's check creditworthiness of the customer using the creditworthiness system. This is more or less high-level design, high-level view, how it looks like. And if we look inside how it was designed, it was monolith. So there are all components living in the single Java virtual machine deployed in the OSGI container. And it has already some separation of the services. So you can recognize user service, card service, article service, order service, and some more. There's the top level. On the next level, you see some domains. Idea of the domains was that if the services shared some functionality, for example, user service, and card service has some functionality related to the customer, they go in, this functionality will implement it in the domain. So there are a number of domains that it's shared between number of the services. There's a huge core domain that all common functionality located. This was mixed from the business and technical functionality, and this will be really shared everywhere between domains, between services. And communication to the database was implemented those, and there are some connectors to for messaging and SAP. This is architecture inside. The first question was what was good with monolith architecture? The first one, with monolith, we have quite quick start and first achievement because the deployment, the infrastructure is quite easy. The implementation also straightforward. Yeah, we shouldn't think a lot about communication between the remote communication. It's very fast start. The second, also have quite a simple build and deployment pipelines because it's just single project, single repositories. Very important, also my observation that if we start with monolith, there's a more or less homogeneous approaches to design APIs, graphical user interfaces, and the general approach of architecture. You can easily provide the best practices, some styles, some blueprints, and team is easy to, let's say, to ask team to follow the rules, even some best code practices, and it will be homogeneous across all projects. Yeah, communication between the teams also easier. Use mostly Java interfaces. So in OSGI, there is a possibility to decouple a bit components using the Java interface. It's one component see only the interface, and implementation is completely hidden. But still, there are no remoting. You just call interface method in the another component, and that's it. Easy monitoring is a single bubble, so it's of course a lot of happens inside, but monitor in sense of communication is quite easy. Yeah, also there's a single deployment and development guidelines. Not always optimal, but at least a single. It's all the one for whole teams. And of course, as DevOps has an easy way, so easy life with monolith because it's just a single application, and they should care only about single application. Of course, it should be scaled. It runs the different instances. It should be scaled horizontally and vertically, but it's still only single application using the single technology. But with the time, the start was good. But after that, the system grows and the teams grow, and we see some issues, some challenges with the monolith. The first, what I observe, that migration of the new libraries becomes very difficult because you need to synchronize with 3 teams and prepare the whole system to be migrated. For example, migration to Java 8 takes about 4 or 5 months. So to go to another Java version. Resilience. So we have some production issues because components use a shared thread pool, HTTP thread pool, use shared DB connection pool, and if one component has a problem for some reason, they blocked working, and the thread pool, common thread pool, is exhausted very quickly, and the whole system stop answers. Yeah, so you have really complete system down. So deployment was mostly problem by development time, because if one team has a issue, has a error in component, it could easily break the whole deployment for all other teams, and all other teams are blocked until the bug will be fixed and deployment works again. I also observe that development cycle becomes very slow. So until the time between you fix something or implement the new feature and you can test it takes 15-20 minutes, sometimes even half an hour. So it's quite long because system grows, it's complex, and even locally deployment is also complex. It's quite difficult. It's possible, but difficult to bring innovations because the team who try something affects another teams because it's still the components running in the same processes, the same virtual machine. Also, there's a problem with scalability because you can either scale all or nothing. So we have we use the Google Cloud provider for that. It's quite easy to create a new virtual machines, but again, you need to with a peak time. So peak time for e-commerce was about Christmas. It was very factor 2, factor 3 more requests, and we need to scale for this time the whole system. It's not possible to scale different components individually. And if the new members join the teams, the learning curve becomes more and more complex. And also, I will see that some people just scared to change the code in some places of the system because that they just scared to break the stuff. So some place of code really owned by only some experts, and nobody else feel confident to change something. This is the challenges what I observe. Then we decide to perhaps we need somehow to split the system. Of course, it's running e-commerce system with a lot of new requirements. The business grows. We have enrollment of some EU countries, and we cannot say, dear managers, we will stop development for half a year and we'll split the monolith. This was not really acceptable. Therefore, the first step was very important to decouple consumers from the rest of the system. So it's kind of gateway in between. So the consumers talk to gateway, and they don't see the changes. The splitting of the rest of the system is transparent for them. This opens the door to extract, to cut some parts of the system deployed independently, but still don't break the consumers. They still working with the same API, the same gateway. And internally, gateway is responsible to redirect the calls to the new components, new subsystems, or keep some kind of request with the old one. Even we can do kind of canary releases. By deployment of new microservice, we can put, for example, 10% of traffic on that and see if it works stable, then switch completely. So this kind of functionality is also possible with gateway. So it's a step 0. After that, make a second step, and I recommend really to do it. Just select, choose very simple, the simplest service to extract. Normally, it has a minimal dependency on the monolith. The rest has perhaps own data store already independent, so the extraction is easier. You can train on that easier step, and you have some success already. So you can also report to management. Yeah, we have already on production first microservices, and as fast as happens, the better. And very important, don't to test and don't to care about architecture a lot, but really try until production. So really deploy the first part in the production as soon as possible. Only in this way you can learn, you can train. The next step was after the extraction the simple services. I will recommend to extract the services that hurts a lot. So they really produce a pain for the team. But in our case, it was price and availability service because the load of the price availability is much more as the others. Because prices are asked from different places, asked from the product detail page, from the cart, from the checkout. So, and the traffic on the price and availability parts component was factor 10 more for the cards, for example. Therefore, we just extracted to scale independently, to have a possibility to provide more instances of the service. This is step 2. The next step becomes a bit complex. So until this step, the refactoring was quite easy, and extracting, we don't have a lot of changes in the code. After that, we should to deal with the user card checkout order services and the problem that they are really coupled together with domains. So we have a real really issue to extract it independently. Therefore, the first step was to make independent code bases for the system. We just, on the first step, we just copied the code. Really takes the domain and copy it completely to the other team. We end up with some duplication, which violates don't repeat yourself, dry principle. But gain of that was that every team has independent code base and can refactor it, can improve it completely independently. Gain was much more, of course, sometimes if the bugs or new feature comes, you should fix it in some places, 1 or 2 or 3 places, and test it in some places. But gain of that was much more important for us, that we provide independent code base. After that, one after another, extracting user service, card service, checkout service in the separate deployment units run in Docker. But they're still not real microservices because they still use the common database. Yeah, they access Postgres tables, and for example, card service use a join to get the user information. Therefore, it's still not real microservices. They have some dependencies on the data level. But we have already some gains that the teams could deploy independently. They can scale independently, but they still should synchronize and approve the changes in the DAO and the data model. Therefore, the next step was to decouple databases as well. And I would say that it's most, from my point of view, most complicated task. So split the code is not so difficult, but split the data is really on production is really hard. There are some approaches to do it. I depicted 2 of them. For example, with user service, I have independent user database. It's only users saved. But of course, card service needs some information about users. Yeah, so early it just database, make a joins, and receives the information about users. After that, we do it just through the REST interface. So instead, going directly to database, card service asked, make a calls of the user and gets the information what necessary. Of course, the cost of that is performance. Yeah, so it's instead the direct database call. We need to go for the REST. Another approach was between card and checkout. We have independent database as well, but checkout has a kind of copy, kind of clone of the card database, of course, only with attributes what's interesting for checkout. And if any changes happens or card is created, there is an asynchronous mechanism, asynchronous way to keep this information in sync. So if there are some changes in card service don't only modify the data, but also publish some event into the queue, and checkout service based on this event updates their own copy of the data. So it's kind of replication. We use the asynchronous mechanism. Cost of that is that we have not consistency anymore. We have eventual consistency. You cannot guarantee that this data will be in sync immediately, but you say it will be in sync, but perhaps in some seconds or minutes. And you should, of course, check this the business case if it's acceptable or not. And target view, it's really the picture which I really like. We have all services separated, extracted. They run in the Kubernetes cluster using the Docker. We'll speak about a bit more later about that. And very important, they have completely independent databases, data storages. After that, the teams could really experiment with technologies, deploy independently, works completely independent. You can even take one microservice, one service and replace it with completely other implementation, or nearshore, so outsource the implementation to the other team is much more flexible. But of course, microservices is not a free lunch, and there are also some challenges that we have. I split it into the 2 groups. First is the technical challenges. First, it's absolutely necessary to have CI/CD pipelines. So even with Monolith, sometimes it's possible to do some manual action. With microservices, it's no go at all. So you should, from the beginning, create a working CI/CD. It's absolutely must. A monitoring solution is necessary because now you have not a single system. You can look into some controlling tool, the JVM helps you or not, but you have a number of the systems working in the different processes, and you absolutely need to have a overview, a picture of that. Also, centralize logs and Elasticsearch with Elasticsearch. We have, after splitting, we have a number of subsystem microservices have a number of instances, and every subsystem writes its own log. And we have absolutely necessary to have a possibility in one place to search for the error if something happens. And also we have some patterns in the logs that catch some kind of exceptions and report in the chart. So push notification actively if something happens. If for example, something new or some new exception we are not expecting happens, we have automatically notification about that. Or if in 1 minute happens more than 100 exceptions, we also have kind of notification. And messages tracing and debugging was quite important, that we can trace, see, identify which subsystem the message goes through and which time spans of each subsystem. So message tracing functionality is absolutely necessary. There are also some organizational challenges, some organizational problem. The first that you make a teams independently, works more effectively, more fast, but you end up with heterogeneous style APIs, for example. Yeah, so some people some teams prefer Java first approach to design the REST API. Some of teams making the contract first. Their approach is a bit different, and you lost this homogeneous view of the system as it was in Monolith. Also, GUI design could be different. Architecture style, some teams prefer event-driven architecture, some teams makes more synchronous calls. So it's very difficult, it's even impossible to enforce homogeneous APIs, architecture, and GUIs in the system. There are some features that requires changes in the different services in the multiple teams. It was quite difficult to implement them. You need to synchronize a team. Also, central QA was quite impossible anymore because the system subsystems are so complex that there is no single team, not single QA person who aware how every subsystem works. And there also was some mistakes in the subdomain splits and the team responsibilities. I will explain it a bit more in details later. Okay, how to resolve the technical challenges. And perhaps I will make a short break and check the questions. Could we have a code the example project later? It's unfortunately not example project, it's a real production project. That's I cannot provide the source code of that. But of course, there is some kind of models, something like this in the simple way, and in the kind of tutorial how the microservices should look like and how Monolith look like. So I try to find it as in the code bases. Any other questions on this phase? Model tutorial would be also very helpful. What do you mean under model tutorial? Perhaps you can explain it a bit more. Tutorial sense of step, but which iterative step happens, or tutorial. I mean, oh, okay, okay. So you mean the sample code? Okay, good. Good. If there are no more questions, I will go ahead and see how to resolve the challenges. This CI/CD pipeline is more or less standard solution. So we provide such a plugin that produces builds the Docker images for SpringBoot application, publish it in Docker registry, and using the Terraform Helm chart, these images will be deployed in the Kubernetes cluster and managed there. So just by every code change, the CI/CD pipeline works. They run the unit tests, slice tests, deploy, they run integration test afterwards, and you immediately see, without any additional actions, you will see as integration tests are green or you break something. Monitoring solution, we use commercial solution is Instana here, but important that you have you must monitor some technical parameters, technical characteristic of the system, like heap memory or number of threads or CPU load, but also some parameters for services, for example, how much calls it was, what is the latency, what is the percentage of the error rates, and so on. This is quite important to see per microservice. For login solution, so how login works. The best practice in the cloud native application that they just not treating any files, but just produce output console login. And in our case, we use a special flying bit parser to pre-parse these login streams and send the information to Grelog server. Flying bit parser also identifies some variables like response time. We can fix it and provide for Grelog server as a variable. You can also then afterwards you can run queries for logs, like I would like to see how much a quest takes more than 1 second. Yeah, so some variables are really extracted and parsed there and can be used later on the Grelog server. Logging and tracing solution. So logging, yeah, it's just a query for a Grelog, and you can find across all system. Important was that you really have a central place you can set all logs. This was quite important for us to have. In this case, I just get the ID of the message of the card and go through the whole logs, and I see all requests using this card ID, for example. For tracing, we have proprietary solution, was not very optimal, but it works. So we generate span ID ourselves in the JAX-RS filter, and then with MDC logs, the span ID logged with every log statement, and the client should propagate span ID either in synchronous or asynchronous calls. You see this is part of Grelog, and you see the span ID is long-running ID, and this is really a span ID for a message route. Normally, if you have an error or client reports some error, you're asking for session ID. After that, you can see all relevant messages, log messages for this ID. And you can analyze this only one request with request ID, with a span ID. This was quite important to analyze the problems, analyze the errors. Otherwise, we have very bad chances to find anything. Alternative, of course, is a SpringBoot out-of-the-box solution is Slois using the Zipkin Brave server. You can also generate span IDs automatically with injected clients. And even there's some GUI in the Zipkin there, you can see how much, what is the call stack, see which parts message reach, is a MySQL, cache, persistent storage, and how much time it takes on every step. To analyze performance problems is a very useful tool to see which components is bottleneck. Organization challenges, how we solve it. Heterogeneous design style. Yeah, we make some best practices description, show success stories. If one team has a really good experience with some approaches or some technologies, you can expose it for other team, common workshops. But I really avoid to force and press the team's decisions. You shouldn't say that all teams should use Log4j, for example, yeah, or all teams use only Java first API design. Of course, you can end up with the heterogeneous stuff, but it's a trade-off. Because of that, you gain the flexibility and agility in the teams. Also, team works really quickly, faster. Features span multiple services. Very important to define contracts between microservices. So it's only they communicate using these common contracts, and the features that need to changes in number of microservices could be done in compatible ways. So also in the contract and the APIs provide the changes mostly in compatible way, or if possible in compatible ways that you can deploy already in production your component with new functionality and they still work with old microservices as a previous structure. So then you avoid to synchronize the feature across all team and all should deploy it at the same time. That's really difficult. But I would say also if there's a lot of such features that span microservices boundaries, then perhaps something wrong with your splitting. So you should rethink the concept of splitting microservices with microservice boundaries. It could be the case that splitting is wrong. Central QA, I would say it's quite difficult to control it centrally. And what we did, we really worked with the team is responsible for the whole life cycle of the service. So from the design, implementation, tests, deployment in production, analyzing the production issues, scaling the system. So completely it's done by team. So QA central, so DevOps team exists, but the more helps to support the teams. They don't do independent job, but they support the team or play some common infrastructure stuff. Yeah. So basically the teams are responsible for you build it, you run it. Yeah. So yeah, completely responsible for production tickets as well. Yeah, it's very nice that the team becomes the tickets from the customer. They immediately see this implementation is the right way or not. What was quite painful if the splitting of subdomains is wrong. Yeah, so I also see in a lot of system, a lot of customers, for example, the microservices are too small. So the customer produce kind of nano services. Therefore, these mistakes, unfortunately, are very expensive because it's not only technical split. You normally also make a kind of organizational changes because the team is responsible to produce a subsystem. And if organization is not flexible enough, the correction of these mistakes are very, very expensive. Therefore, my recommendation is first train on Monolith. So don't really start to produce a lot of subsystem, a lot of microservices, but try to isolate the subdomains in Monolith. Yeah. So, for example, put the subdomains in different packages is the first step. Make the clean interfaces that the parts only dependent on interface and use the dependency injection for that. Consistent naming is very important. And train on that, split the classes between these boundaries, refactor the stuff until you're really feeling that, yes, this is part is more or less independent. I can extract it into the microservice. And also clearly communicate with the manager and plan the split, because of course there are always a lot of features, a lot of the requirements from the business, and sometimes the team say that there are no possibility, no option to make this kind of refactoring on extraction. So it should be planned, and it happens iteratively. Also very important that the still monolith system evolve, and new features is implemented in the production, but in parallel you split in already parts of the system and brings in production as well. And it's a good idea to review the boundaries and after some times, and update it if after the system involvement. Sorry. So if the project grows and system involvement, it could be the case that splitting of the boundaries in microservices is wrong. It's not fit anymore for the new functionality, and you should make a step back and rethink it. Okay, some conclusions from like kind of summary. So there's no wrong or right architecture. So you see every option, microservices, monolith has their own challenges and advantages, or pros and cons. And it really depends on your use case, business domain, development perspective, what kind of architecture you choose. So monolith is not always bad. For some cases, monolith fit perfect and works much more better as a microservice. So you should not split microservice only because of it's cool. Very often, my observation is starting from monolith is faster and pragmatic. So you just start with monolith, train a bit with monolith, and only after that you bring this complexity with the service, with the microservices. Also, I will split monolith microservices only because of good reasons. So either you have problems with new technologies, or deployment one team breaks deployment to other team, or you see problem with scalability, you cannot scale system independently, or you see a problem with resilience, that on the production the system is fragile. If you see it, yes, then think about splitting stuff. If not, if system works good and you have no reason to split it. Also, splitting process should not be big bang. I would recommend to do it iteratively and use a strangler and gateway patterns for that. So gateway I already shows it's the part that's the abstract clients from the system, and strangler pattern is exactly what we do. So there's a old system, and you step by step, part by step, or part by part cut the functionality, and the old system becomes smaller and smaller and disappears in one day. So I would recommend to start with a simple service that have a success as soon as possible, and after that, it's critical services that have produced some pains. Also be aware about technical organization challenges after the split, and be prepared for that. So provide the logging solution, tracing solution, CI/CD pipelines, monitoring, to be prepared that one day your system, a single monolith system, becomes a number of distributed subsystems. And yes, mistakes of the microservice boundaries, unfortunately, it's very expensive. How to completely avoid is not possible. You will do these mistakes, but you can train a bit on still on monolith, and periodically rethink your splitting. Say some signs if you have a lot of features that have across the they span the microservice boundaries. Or you should synchronize the teams very often. Then is a sign that perhaps your splitting is not correct anymore, and you need to update it. It's absolutely okay if the architecture after some months or some years becomes not optimal, because architecture is not the stuff or the things that we design one time and forget about that. Architecture is evolving and growing process. And it's absolutely okay that after new functionality, new features, new components, you rethink your splitting and perhaps merge some microservices together or extract the new microservices. Yeah, that's basically all from the presentation. Now I will go through the questions. And you can, of course, you're able to ask a new question as well. So I will just see what already asked. Do you have application, some application level monitoring besides threads and errors? Are the KPI changes after splitting? Application level monitoring, yes. I already said that monitoring inside the application very important, but also not only technical parameters, but also some business parameters like how much, which kind of requests are there, what kind of, is this B2B customer, B2C customers orders are there. They can also adapt a bit business. So if you see that B2B, there are a lot of B2B customer requests, you can perhaps scale and put a focus on this part. What is very useful really to see per call. So if there is a problem on the system, the component, it's very important to identify exactly which microservices is the problem, is a bottleneck. And for this tracing stack is quite important that you see per microservices, per component, where the messages have any errors and up these errors, or where they takes a lot of time to be processing. Is it either it's database, is it storage, or is it network communication, or is it thread pool in the component? So this identification should happen quickly, and basically this is really crucial things for the monitoring. Other KPIs change after splitting? Yes, performance, I would say, stays approximately the same. We have not a lot of gain. They have not a big drawbacks, but not gain regarding the performance. Perhaps it's even a bit worse as was in Monolith. But we win a lot of because of that. We can win performance with independent scaling, for example. Yeah, so for Christmas or for the lunch time, there are normally more B2B orders, and you can dynamically scale the system for that. Therefore, also costs, so hardware cost was also more, so we should pay for infrastructure more with microservices as for Monolith, definitely. It's again the trade-off between your cost and what you win with flexible and fast development. How big the monolith was? Did the example with 4 microservices was a real example? I would like to know if there were any changes in team were working on the software. Of course, it was more than 4 microservices. It was about 20, I would say, and the end. Monolith, I'm not sure how much lines of codes, but I think it's about 1 million lines of code in the monolith system. So this was really huge. Therefore, it was really time to split it, because working with that kind of big system, especially migration was a pain. Yes, if you need to migrate a new Hibernate version or new Java version, it takes really months to do it. So if you observe that, it's perhaps that's really time to split. Okay, it's about IDEA license. Perhaps I will redirect these questions to Selma.
Yes, I heard my name. I'm here. It's probably because of the IntelliJ IDEA license. I'm already giving 2 away now, but hey guys, I just checked and we have 1 more. So if anyone is interested, just write me a message on meetup.com. Okay, so now Pavel is writing you, Andrei.
Okay. How do you manage the teams? And what is the squad guides approach the taking over the domains? And what is about knowledge sharing between the teams, any give and takes? Yeah, it's a very good question. Of course, management of the teams becomes more difficult because teams are independent. So synchronization between teams are difficult. Therefore, the first recommendation that I have, let's have as less dependencies as possible between the teams. And the most important communication way is a contract. Yeah, so the microservice subsystem has a contract, has an API, could be synchronous or asynchronous. And this is basically our point to communicate to other teams. If we implement the new extended API functionality, it should be communicated, it should be published, should be available for the other teams, should be announced. We have normally, if a feature requires functionality from other team, we explicitly plan it as a task to synchronize with the guys, understand what changes should be done or was done in the other system, and after that plan also timeline, because sometimes it's not possible to start implementation of one microservice until the other microservice is ready with the new functionality. It's a bit complicated also for product owners to plan the sprints because they need really to synchronize the tasks, but there's no other way. And stay compatible with the APIs, also very important, not to break, or if you have breaking changes, you should keep compatibility for some releases that all clients migrated, and only after that removes unnecessary or old functionality. Knowledge sharing about teams, we have per week 2 common workshops, meetings, architectural and so team lead workshops. They discuss common problem and share the best practices on these meetings. If I start a new project now, is it better to use Java 17 or Java 11? It depends, the answer. It depends for a lot of factors. First, I would say, do you really need do you need the new features of Java 17? If no, look to the system experience, to your team experience. Either the team members are starting with a Java, so Java 17 faster and feel confidentially as with Java 11. So it's really my decision about new frameworks, new technologies based on the team experience, because sometimes even I refuse from the cool features, the cool new frameworks, only because it's difficult for the new team members and for the team members to work on that. It should be really, it should be a learn process. You should try the new stuff, but always take take in consideration, takes in it's a reason of your decision that it could cause additional time for the teams to adopt this framework, adopt the functionality, and for the new team member, especially if the framework is not mature enough in the market, and difficult to find people who are experts in the area, in the frameworks, be careful on that. So therefore, of course, feel free to start with the Java 17, but it's okay to start with Java 11 first, and after that migrate. Also, the huge advantage of the microservice, you can migrate it very quickly. So if you make a wrong decision, it's not catastrophic as a monolith. You can completely replace the technology, completely replace the microservices, even if it goes wrong. And if you start with Java 11 and see, I need something for Java 17, you can migrate it very quickly with the microservice world. Would you mind if I ask how many teams and how many employees are working on the projects, just to give me an overview? I say since the beginning that it was 3 teams, 7-8 persons each in the beginning. So this was about 24 persons, and to the end it was 60-70. So this is number approximately. Any more questions?
I guess that's it. There's no more questions on the chat. Oh, there's someone writing.
Oh, there's some. Having different databases in microservices brings this a lot of complexity. One of them is joining data from different databases. How have you dealt with this in the past? Basically, I explained this with the slides. If I go a bit back, I'll select correct one. There is some approaches. Yes, this basically is the most complicated part from my point of view in the whole migration. Yeah, this is the correct one. The data splitting is most complicated stuff. Yeah, it's more complicated as a code split, because you need some migrations, you need to adopt the APIs interface, you need to adopt your DAOs, and it goes through the whole code sometimes. Yeah. Therefore, I even make a first split the code. The microservice still use subsystem use the silk share database, and only after that I split the data. It could be another way around, of course. I use 2 approaches here, either to ask data from the API or make asynchronous replication of the data. And the one service has a copy of the data of other service, and using asynchronous mechanism just replicates the data between. With issues with asynchronous messaging and database transactions? It's very good questions. Yeah, how we deal with transactions across all tables, and will guarantee your ACID, so atomacy, consistency, integrity, and durability. Yeah, and of course, microservice world is a bit different. It's a bit different. You cannot do it so easy between the microservices. Our usual approach, and I also use in my project, is a compensation transaction. So for if you need really some actions as a to have atomacy between two actions, so all or nothing, you need to create some kind of compensation calls. Yeah, so system A creates a user, for example, or and system B create a card for user. And if the card fails, we don't need user as well. So the kind of transactional behavior. In this case, system A should roll back the creation of the user. We should have some compensation activity. So I use in microservice world, I use mostly compensation transactions. But also it could be a sign that you have a lot of, if you have a lot of transactions across the microservices, then perhaps your split is wrong. You should rethink your split in architecture, because normally transactions should happen inside one microservice, and also as one criteria to define the microservice scope, how long a transaction it takes, where transaction begins and ends up. Did you have to make changes on the front end to accommodate the eventual consistency? In front end, for eventual consistency, not really, but some use cases, some business use cases will be was adopted. That's the user. Some business processes was changed that the eventual consistency is acceptable for the business. For front end, I also split the front end a kind of complete slice, so vertical slice. That's a front end part belongs to the microservice subsystem, and team works all together. So front end developers and back end developers, because this slice connection between the back end and front end in this slice, it's heavy, but connection with other slices, bounding to other slices is less intensive. It makes sense that the teams who produce this part of functionality really works together. Therefore, it's not really microservices, a subsystem, I would say. Yeah. So complete the card has, for example, own GUI, own microservice, and own database. We have completely independent subsystem in this case. Yeah, so the eventual consistency could be a problem for some business cases. If you work in financial rewards with bank transaction, then perhaps eventual consistency is not acceptable, but then just put it in the single microservices and use SQL database instead, not SQL. It's absolutely okay, but you have a good reason to keep the stuff in the classical transactions properties like ACID. Any other questions, or perhaps you can share your own experience?
Any more questions? Okay, everyone.